Hello guys, today we are going to study about conservation of mechanical energy in circular motion. So basically, what is this mechanical energy? So this term mechanical energy means the sum of potential energy and kinetic energy. Now, the energy possessed by an object by virtue of its position or configuration is known as potential energy. So for example, a man on the top of the hill is at some height, so it has some potential energy. Similarly, the energy possessed by an object by virtue of its velocity is known as kinetic energy, right? So sum of these two energies is nothing but mechanical energy, and according to law of conservation of energy, this total energy is said to be conserved. That means initial energy should be equal to final energy. This is constant unless and until work is done by an external force. Today I am going to explain you conservation of mechanical energy in circular motion with the help of this example. Now consider a scenario where car is at point X and it is going to move all through this way to Y and then go till Z, right? So it's going to traverse this circle and come back, right? So now this is a toy car whose mass is m, height from the ground is given, and it is released from point X. So when I say release, that means initial velocity is 0. And we have to do 4 parts related to this question. So the first part is you have to find the velocity at point Y. Second part is you have to find the normal reaction at Y. Third part is to find the velocity at Z and then normal reaction at Z. Some people call it N or R. So these 4 parts will be are unknown variables, and they can only be solved using the concept of conservation of energy. Now let's find out the velocity at point Y. So as I said that we have to apply law of conservation of energy, so that means that total mechanical energy at X should be equal to total mechanical energy at Y. And we know that mechanical energy is sum of potential energy and kinetic energy. So when I say energy at X, that means potential energy at X, kinetic energy at X should be equals to sum of potential energy at Y and kinetic energy at Y. Now let's consider the height at point X is h. So that means potential energy is mgh. G is acceleration due to gravity and h is the height from the ground. But now initially it is just released, so my initial velocity was 0. So that means initial kinetic energy is 0. Now at point Y you are on ground, and ground is my reference point in this situation. So that means my potential energy is 0 at Y and kinetic energy is half times mass times velocity at y square. So that means my equation becomes mgh equals to half m vy square. Now m and m gets cancelled, so from here I am going to get my general formula for velocity at point Y as square root of 2gh. Now we have to find normal reaction at point Y. So let's first consider the diagram again. Now this is the point Y and this is where my car is lying, right? Now the weight is a vector quantity. It's acting in the downward direction. Now the net force is the centripetal force, because this is going to move in a circular path when it reaches Y, right? So that is my net force. Now the normal reaction would be again in the upward direction. So centripetal force is my net force, right? So how would I write the equation to find the normal reaction? That my net force, which is my centripetal force, is equals to sum of two forces, normal reaction and my weight. Now by convention we are going to consider the downward direction as, according to vector analysis, as negative direction, and the upward direction is taken as positive. So right now my centripetal force would be m, because we are taking y point, so velocity at y whole squared by radius of the circle equals to normal reaction, that is what we have to find, plus, but weight is acting in the downward direction, so I am going to write a negative sign. So from here my normal reaction would be mvy squared by r plus mg. Now, as I have calculated the velocity at point y in first part, I can substitute it over here and then I can get the normal reaction at point y. Now, the next part is to find the velocity at this point z. Again, I'm going to apply the law of conservation of energy. That means initial energy should be equal to final energy. So, initial energy at x, as we calculated in part A, was just the potential energy. And the velocity is 0 because the object is released at that point. So, the only energy that I have at point x is potential energy. This should be equal to potential energy at point z plus kinetic energy at point z, right? Now, to find the potential energy of at point z, you have to consider this height from the ground, and this is nothing but the diameter of the circle, which is 2 times the radius. So I'm going to write it as mg times the height, which is nothing but 2 times the radius, plus half m velocity at z squared mgh. Now in this equation I can cancel out masses like this. So GH equals to 2GR plus VZ squared by 2. Now, what I'm going to do is I'm going to calculate the velocity of VZ, which is GH minus 2GR, and from this point VZ will come out to be square root. On simplification, you'll get square root of 2 times G will come out to be common, H minus 2R. This is R. So that's my formula for finding the velocity at point Z. Last part is to calculate the normal reaction at Z. Now I'm just going to consider the upper half of the circular portion, and this is my point Z. Now my car will be like the upside down, right? So this is how my car will be at this point. So in this situation, normal reaction is downward, weight is also downward, and centripetal forces towards the center of the circle, which is also in the downward direction, right? So now the centripetal force is my net force. Now as I did it in B part, so net force is equals to the vector sum of other two forces, which is weight and normal reaction. Now centripetal force is in the downward direction, so negative sign, minus m times velocity at z point squared by r. That's the formula of centripetal force, equals to, again weight is also in the downward direction, plus normal reaction. So from here my normal reaction comes out to be mg minus mvz squared over r. So as I have calculated the velocity of z in part C, I can substitute it over here and calculate the normal reaction at point z. I hope you guys understood the concept of conservation of energy and how to calculate the velocities at different points and normal reactions at different points during circular motion. So subscribe my channel for more upcoming videos and stay updated with my channel. So till then, stay happy, stay safe. Thank you.